27 or 28. If I'm only coming in with 24, can I get 115 going out? No, you can't. You have to have what it says to input to give you an output. So, you will find that you're coming in with 24 and you're gonna be going out around a 110, okay? Will be your output because you're much lower coming in than what the inverter was designed to handle. We understand that, right? We can agree with that, right? It's not that I have a weak inverter, it's just that it didn't have the amount of input that made it work to its full potential, because they just don't make a whole bunch of inverters for all these different applications. So, when we come out, that means anything coming from A on that circuit becomes AC, so why are you on your AC part of your meter? You have to look at it, you have to know. That's why you pay for troubleshoot, to make sure you set up prior to utilizing it. Okay, now, the things we have to know in addition here is we have a silhouette. This silhouette will end up being your, it's gonna be a selector, and that selector has 3 rows behind the panel of wires that connect to the one selector. Okay, it's your air conditioning selector. And it has a vent, it has an off, and of course all electrical diagrams are in the off position, aren't they? On the non-power position. So, we have an off, we have an off, we have an off. These 2 poles are off. It's one selector with 3 rows of wiring that are behind it. That's why it's all in this silhouette, to show you that's one component but 3 rows of wiring. Now, let's talk about the top one. So when I go to select, it's coming off of off, and I have chosen to go to vent. I've chosen to go into auto. I've chosen to manually go to warm. I've chosen to automatically go to cold. I've chosen to go into a dead spot where this goes to this one. So if I want to go to vent, guess what? It goes to vent, it goes nowhere, it goes nowhere. Okay? So when you draw one, you must draw them all. You will find that I only care about the vent line, don't care about this, didn't go anywhere, didn't go anywhere, still draw it in. So you can see that I do not troubleshoot this. I only care about this, right? Right? So make sure that you're not wasting time. That's why we pay for troubleshoot. Every time you pay for troubleshoot, you know what you need, what you don't have. Now, what I need is a better writing utensil here. Okay, so for the vent, what is this symbol right here? What? Relay. Now, we have different types of relay. We have mutual induction relays. We have relays, of course, with an iron core. And that part I really don't care, just so you realize it's a relay. So when you say a relay, how can you, okay, I don't know what a relay is. Help me to know what a relay is. How would you describe it? That's exactly what I would like to hear. It's an electrical switch. So in the cockpit, I have this very small switch in the cockpit. All right? And very small. But the vent blower is this big in circumference. It's up big and it's mounted on the fuselage, big bolts and all that. It's a pretty big unit, right? Yeah. And it's a DC motor, because we know we're working with DC. Right. And what do we know about DC motors? They draw several times the rated current, right? Right. So they are going to be a high amperage for our power, right? Now, to turn that motor with that switch, is it possible? Yeah. That switch wouldn't last very long, no how. No, I know an airframe with Bill, you should have, see when I teach turbines, we have to do power plant electrical, and of course I make you then determine what size switch to go into what circuit. Did Bill do that? No. Well, it's in your airframe book. It's in your 4313 on you determining what kind of rating switch you need for the circuit. But we can have a very small circuit in the cockpit because why? We have an electronic switch here. So this circuit here is called a control circuit. This circuit here is called the power circuit. Power circuit is going to be a much larger, nope, take that back. Got it backwards. This is my control circuit. This is my power circuit. Because all I'm doing with electronic switch is bridging the gap to a value that should, and of course, this isn't really representing with a real airplane. This amp, this guy right here most likely would be like a 20 amp, and then your control circuit is your 5 amp. You see what I mean? Because if I did not have that electronic switch be my relay, and I wanted to go switch to motor, that's gotta be a much bigger switch. Because what is a switch, what is a circuit breaker? Circuit completers.
Yes.
They're not considered a load, they complete the circuit. But because we've incorporated an electronic switch, we have a control circuit. So I want this vent blower to work. So in the cockpit, I'm gonna go ahead and coming through my control circuit, comes over here, I meet that, comes over, it's standing by, but we have something that I can't get the ground. So the first thing when you troubleshoot, you need to find your power, find your ground for the particular circuit you're looking at. So I have a ground, and then I'm gonna have a ground for the motor. So these two guys here, I've got to get to. Well, how do I get to them? You get to it because when you hit your control switch in the cockpit, and we select that, then it gives me my power, everything's good, except the right here. Now, I told you earlier, we only use a vent blower on the ground. Once we go into the air, we use ram air. Okay, so, and in this case, you don't even use a vent blower outside of being on the ground. So that means that your landing ground switch has to be on the ground. Once it's on the ground, you know you have energized the relay, pulls down your magnetic core there, power comes across, finds at the ground, vent blowers run. So in this particular case, you have two circuits you have to troubleshoot. Right, a control circuit and a power circuit. We good? Straightforward? Straightforward because you know the components, you know how they work, you know how to draw it out. Now pick up your meter, because I'm gonna say that the vent blower's not working. Is it the vent blower, or is it the control circuit that gives you the power to give it power? So then you have to go to your relay. Hey, do I have power here? Yes. Do I have power here? Yes. Do I have power here? Yes. Do I have power here? No. Well, then we have a problem. Okay? Most likely the relay hasn't been energized to pull it down. Alright, so that's like a scenario number one. So now, let's take a look at something that when you read about the system, we have to have some protections. So, we have other things. We have a control box. This control box is only AC. You can see this cannon plug and this cannon plug only gets its power through AC. Okay? Now, things happen when we're over here, but when we look, we can see 2 is DC. We see 3 is gonna be AC. We see 4 is gonna be AC. We're gonna see down here is AC. And then we're gonna be down here is gonna be DC. Okay? Alright, so when we look at our test strip or terminal strip, number 1 bus, we have our air supply valve. None of the air conditioning work without an air supply valve. We have that as a source of air, right?
Right.
Okay, and then down here we have duct sensors. Now, you're going to see duct sensors and cabin sensors. Now, you're looking at that symbol. What does it tell you? What kind of symbol is that? A what? I don't know what kind of symbol is it. The duct sensor is a resistance type of component.
Yeah.
But as a resistor, what are the different types of resistors we have?
Variable.
Okay, where's my variable on my diagram here?
So a lot.
I don't see one.
Yes, you do.
I
You
looked at
said it, look, look at it. Where's my variable resistor?
It's. I don't see one.
Is it the
Cabin temp selector. That's a variable resistor, isn't it?
Exactly. That's not what it's doing.
Oh, yeah.
That's what you were about to say. I know it. But she said it, you were about to
Oh,
say
yeah,
it.
she just beat me to it.
The rest of you are liars. Okay, that's a variable resistor. So that means, so what kind of resistor detects temperature?
Bigger.
No, variable is you adjust. I want full power, I want partial power. What? A what? Yeah, what? Yeah. Did you say tachometer? did this.
No,
A thermometer resistor.
Where you, what?
Thermometer resistor.
You're getting closer.
A thermo resistor.
There we go,
That's what I
it's a
was
thermo,
gonna
I knew you were gonna say it. Okay, this is going to be a thermistor, okay? A thermistor is a resistor that, is sensitive to temperature changes, right? Still all part of the resistor family, right?
Right.
Okay, so duct sensor thermistor, cabin temperature thermistor. Now, I had to replace them, and it was my first time, going outside of the box, give me a part number, I replaced, but this time, Avitech didn't give me any help. So I had to then run my voltage of my system